Welcome to the Organic Chemistry Podcast Lecture. Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to organic chemistry problems. In this lecture, we are continuing with the topic we covered last lecture. Last lecture, we've introduced the concept of hydrocarbons, looked at classifications of carbon atoms such as primary, secondary, tertiary, and quaternary, defined isomers, and then began looking at IUPAC nomenclature rules for naming organic compounds. Now, we finished off by giving the IUPAC names for carbon chains from 1 through 12, that is methane through dodecane. And during the rules, we introduced the concept of side chain substituents. We gave the names of several substituents, but we never explained where those names come from. So we're going to spend some time doing that now. What you see in front of you are the first three carbon chains, methane, ethane, and propane. Now, these carbons chains, IUPAC names, can be utilized to derive the names of the substituent side chains that are related to the straight chain molecules from which the side chains originate. For example, if I take methane and I pull a hydrogen off methane and attach it to a chain, this big squiggle here is my chain. So if I pull hydrogen off, I got CH3, I attach it to a chain, I've made a substituent off a long chain. How do we name that substituent? Well, the rule is you take the IUPAC name, methane, replace the ane ending with YL. And then you've got, in this case, methyl. If you do the same procedure with ethane, pull an H off, attach it to a squiggle or a long carbon chain, you end up with a CH3CH2. Replace the ane with YL, you have ethyl. Interesting to note, no matter whether I pull an H off the right-hand CH3 or an H off the left-hand CH3, I still get a CH3CH2. Now, in the case of propane, I can pull an H off either of the CH3s and I will get a CH3, CH2, CH2, and I can attach that to a long chain. So if this is a side chain off some long chain, it becomes a propyl group. What's interesting is as soon as you get to propane, however, there's another potential site of attachment. What if I pulled an H off of the middle carbon? So I had a CH. And so I'll draw my CH3 down. And then I attach that to a side chain. We have a problem. This is a new substituent. It is a substituent that instead of attaching to a CH2, CH2, CH3, we have a middle carbon with two CH3 branches off of it, attached to a long chain. Structurally, it's very different. Once it attaches chain, it's a different substituent. We can't give it the same name. So historically, this was given a name which meant the same as propyl, and so it was called Isopropyl because it was derived from propane. Now, these names in some cases are names you just have to memorize. So there's no way around it. You just have to learn some of these names. Well, some names are derived from their IUPAC chain roots. Sometimes names aren't. So isopropyl is one of those cases you're going to have to just memorize. Now, what's interesting is the dilemma that arose with two more molecules. So I'm going to clear some room here. And what happened when we got into the case of butane? So let's clear some room and see how that goes. Right. I'll just get rid of the propane case. And we'll start in there with butane. So we're going to jump to butane. we'll just draw a line here. And we're going to start with CH3, CH2, CH2, CH3. Now, butane was an interesting molecule because historically, butane was a name used for two molecules. In IUPAC, this molecule is called butane, but its original common name, so we can put common here if you like. Its common name was n-Butane. N-Butane meant normal. Normal was applied to a straight chain molecule. So whereas the IUPAC was just butane, the common name was n-Butane. Why do they have a name, a special name, for n-Butane? Well, it's because this molecule was also called a butane. This molecule was a 4-carbon molecule that looked different than butane. And so they gave it the name Isobutane. And this was part of an older nomenclature scheme than IUPAC. Because you'll notice if you're using IUPAC, right? Whereas the straight chain, of course, is just called butane. What is this chain called? Now you have to apply your IUPAC rules to solve this. What's the longest carbon chain in the molecule isobutane? Well, the longest carbon chain is 1, 2, 3. It is a 3-carbon chain, and a 3-carbon chain is a propane. So this molecule has a methyl group coming off the 2nd carbon of propane. So this molecule is called 2-methyl propane. Okay, given that the IUPAC name is so different than the common name, you can begin to see that when we start making side chain units from these two molecules, we're going to have some interesting dilemmas arise as to what we are going to call these things. Let's look at some of the side chain examples and then see if we can sort some of this out. I'm going to rub out, just for space reasons, the IUPAC name now. And what we're going to do is we're going to draw the side chains you can get from these two molecules. Now, like propane, n-Butane gives you two types of side chain substituents. Of course, there is the simple straight chain. Okay, so and when you pull the H off the methyl, you can get this long chain, and if it's attached to a longer root chain, this would be called, derived from butane, a butyl group. We drop the ane and add YL. But what is it if instead of pulling an H off the CH3, I pulled one off the CH2? What do you call a side chain that looks like this? Do we do what we did for propane, since it's derived from butane? So there's the squiggle, long carbon chain. This is the way it would attach to a long carbon chain if you attach to one of the middle carbons. Do we do what we have done for propane and get an isopropyl? Do we add iso in front of this? Well, you immediately begin to see the problem. For many years, historically, iso had been assigned as isobutane to this molecule. And now we're assigning a different structure to isobutyl. Shouldn't iso be reserved for isobutane? So we really have a problem here as to what we're going to name this group. So let's come back to this one. Let's temporarily leave it. And let's go look at isobutane. If I pull an H off one of the methyl groups in isobutane, I'll get something that looks like this that attaches to a side chain. So if I pull an H off a methyl, I get a CH2. And what we see here is a squiggle. And that squiggle is a long chain. And so we've got this group. Now, it would make sense if this unit was called an isobutane that when you pull an H off the methyl, just like you did off the n-methyl butane, and it was called butyl, drop the A and add YL, and this should be called isobutyl. And indeed it is. Well, you'll notice there's one different carbon here, other than the CH3s. By the way, what's interesting is no matter which H you pull off, which CH3 you pull the H off, you get this type of substituent. But what happens if you pull the H off this carbon and you attach it to a long chain through the center carbon? Well, you end up with a side chain that looks something like this. I hope I have room to draw this. I think we can make this work. So there's a C here, so there's my 3 CH3s. We attach that to a side chain. Now we have a problem. Isobutane looks like it allows for two different types of substituents. N-Butane looks like it allows for two different types of substituents. And we need some kind of common nomenclature that we can use to name these substituents. Well, what did IUPAC adopt for these side chains? Well, what IUPAC did was look at the carbon atoms that are attached to the chain. Let's go back to N-butane. When I pulled the H off the CH2, one could ask what kind of carbon is the H being pulled off of? What kind of carbon is attaching to the long chain, my squiggle? And if we ask what kind of carbon that is before it attaches to the chain, so before you get it attached to that chain, this carbon had two carbons attached to it, so it was secondary. And they said, since we're attaching through an originally secondary carbon, we'll call this sec-Butyl. Sec-Butyl. It's hyphenated. Because it's hyphenated, sec-Butyl is not used in alphabetizing. I mean, you'd have to use the sec if you were comparing to isobutyl, or not isobutyl, to butyl, because there would be a tie. Notice the I in isobutyl is used for alphabetizing because there's no hyphen between the iso and the butyl. So there's something you have to memorize. You have to memorize the structure and the sec-Butyl term. Let's go down to this one. If I pull the H off the carbon in isobutane, what kind of carbon am I pulling the H off of? Well, this carbon has 3 carbons attached to it. It's tertiary, so this was called a tert-Butyl. So tert-Butyl group. Again, you must memorize this. You must memorize the structure of a tert-Butyl, and you must memorize its name. Tert being hyphenated, again, tert is not used in alphabetizing. Now, what's interesting is what happens when we go to the molecule pentane compared to this. And so I'm going to just clear the board here. And if we do the long chain of pentane, what happens if you pull an H off this straight chain pentane. Okay. And actually, I should probably draw it to save room. So let's redraw that and put brackets around the CH2 and just put 3 CH2s and a CH3. So this is our pentane. Its common name would be normal n-Pentane. So IUPAC is pentane. Common is n-Pentane. And if I pulled the H off, I would get a straight chain. If I pulled it off of a CH3, I'd get a very long straight chain. And so if we just assume our root squiggle chain is even longer, I'd get 5 carbons. Okay, so this is attached to my squiggle. That is a 5-carbon chain. Pentane, ANE would be dropped and we just get a pentyl. So we name this as a pentyl group on the side chain. Now, you might ask what happens if we attach through the middle. Well, good news, you don't have to worry about that. I'm not going to ask you to know sec-Pentyl or anything like that. It is sufficient for you to know sec-Butyl. But there is an interesting molecule which I gave to you in organic chemistry lab when we were learning to draw ChemDraw. And you were told that this guy was called, can you remember? Neopentane. Now, Neopentane is actually the common name. What is the IUPAC name for this? Well, find the longest carbon chain. What is the longest carbon chain? The longest carbon chain is 1, 2, 3. So the longest carbon chain is a propane. And off of the second carbon, we have 2 methyl groups. So if I was naming that Neopentane by IUPAC, I would get 2,2-dimethyl propane. But for substituent purposes, if we pulled a carbon hydrogen off the carbon with the 3 hydrogens, the terminal carbons, then I have dropped the ane of Neopentane, and I have the group called Neopentyl. So this is a Neopentyl group. Now there is a tertiary or tert-Pentyl group, which looks like a methyl butane derivative. I might as well draw you that. So let's just draw that up here. Derived from a tert-Pentane group. If you had a butane, which off the second carbon in, this molecule, like isobutane, was originally called Isopentane. That was its common name. Okay. Now, isopentane we could attach at the end CH3, and if we did that, you get something that looks like this, which would give you an isopentyl. So we pulled the H off the NCH3 on the right. That's attached to my big chain. And that would be an Isopentyl. Drop the ane ending, add YL. But an interesting point arises, as there are other hydrogens to consider. Let's get rid of Neopentyl. What happens if you attached it to the tertiary carbon of Isopentane? What would happen if, say, you CH3, CH2, what would happen if you attached it here, where you had two methyls and an ethyl? So it could look like this, or the side chain could look like, let's draw it a different way, look like this. How about this? You could draw it several different ways. It would be the same thing. What's interesting is when it's attached to a side chain, it's the same thing. It's attached to a tertiary carbon. This isopentane derivative, just like in the case of isobutane, when you use the tertiary carbon, was called tert-Pentane or tert-Pentyl. And it's hyphenated. So that would be a tertiary pentyl group. Well, that's as far as we're going to take sec and tert. But you might begin to notice a pattern with the terms iso and neo. What do you mean? Well, suppose I have a long carbon chain, and off of that chain I have a CH2, a CH2, another CH2, a CH, and then a CH3, and a CH3. I can define the term iso, or the use of the term iso in substituents, as being used when on the substituent at the end of the substituent, at the far end from the chain. So used when on the substituent at the far end from a main chain. Okay, so this is the far end from the main chain. If you count one carbon in, you find another methyl. Okay, I can do that. So here I go to far end of my substituent chain. There's carbon, count one carbon in. Count one carbon in, that gets me here. And I see another methyl, a single methyl off of there. This is an iso. Iso what? Well, I just count up the carbons. All of them. 1, 2, 3, 4, 5, 6. What's 6 carbons? 6 carbons would be a hexane. So this is a isohexyl. So you count up the carbons to find out whether it's a hexane, heptane, octane. Just look for that single methyl off the one carbon in, and it's an iso. So it's an isohexyl. It would have to look like this. So in fact, you could name larger ones, and you will run across names like this. Turns out you can do something similar for the term neo. Okay? In fact, I'm not going to rub this off because the neo designation is basically the same definition. What do you mean? Well, suppose I had this guy. Let's go one more than we did last time. Let's try something like that. And we had a squiggle. What's interesting is when I count in, I go to the end of the chain of the substituent, I count in one carbon, I see 2 more methyl groups off that carbon. If there's 2 methyls on the second carbon in from the far end, then the prefix neo is used. So neo is used when on the substituent at the far end from the main chain, if you count 1 carbon in, you find 2 methyls. So instead of another methyl, it's the exact same definition, except at the last 2 words it says instead of another methyl, it's 2 methyls. How do I know what neo it is? Just count up all the carbons. 1, 2, 3, 4, 5, 6, 7. 7's heptane. It would be a hepto. A neoheptyl. No, neo and iso are not hyphenated like sec and butyl are. So this would be a neoheptyl side chain. Now, I grant you that these are getting long, but you should be able to spot them. And it turns out that the common name of the alkanes is also derived this way. What do you mean? Isohexane, for example. Isohexane would look like this. Count up the carbons. Well, if I count the longest chain, that's IUPAC. This is 1, 2, 3, 4, 5. So this is a pentane with a 2-methyl. So the IUPAC name would be 2-methyl pentane. Okay. But the common name, if we go to the end of a chain, go 1 carbon in, there's a single methyl, there's 1, 2, 3, 4, 5, 6 carbons all together, it would be isohexane. That's the common name. The same thing applies to neo. If I go CH2, CH2, CH3. If I count along this is 1, 2, 3, 4, 5, 5-carbon chain. It's a pentane. It is a 2,2-dimethyl. That's the IUPAC name. Dimethyl pentane. What is the common name. Well, a rule for Neo is you go to the end of the chain, count one carbon in. If you see two methyls and it's a straight chain, it's a Neo. Just count up all the carbons. 1, 2, 3, 4, 5, 6, 7. It's a heptane. This would be common name, Neoheptane. All right. Here you've had some common name for side chains, some specialized names for alkanes, common older names not derived from IUPAC rules. It's important that you know the common names as well as the IUPAC names so that if asked for common names, you can give them. Let's look at some other substituents. What if we have a ring, like a three-membered carbon ring? Here's a line formula. This is cyclopropane. Rings are named with the prefix cyclo. It is not hyphenated. Now, what if I told, we know there's two H's here. I can draw it for you. It's a CH2. That was the line formula. I know there's two H's because of the number of bonds in the ring. So here is cyclopropane. What if I pulled an H off and I stuck cyclopropane as a substituent on the long chain? So I have something like this, and it's bonded to a squiggle. Well, that dropped the ane ending. The substituent is called cyclopropyl. All right. What about cyclobutane? 4-carbon ring. Well, cyclobutane, pull a proton off it, you'd have cyclobutyl. What about 5 carbons in a ring? Cyclopentane. Again, not hyphenated. If it was a substituent, you call it cyclopentyl, and so on. So we just add the prefix cyclo when we have a complete ring and just count up the number of carbons in the ring. Name this molecule. Now, it might be hard to see the carbons, so I'll make dots for the carbons. What would that guy be? He's called cyclooctane. Cyclooctane, 8 carbons. And if you pulled an H off and stuck the octane ring on a side chain, you'd have a cyclooctyl attached to the chain. Let's look at some others. What happens? Oh, maybe you can tell me what this molecule is. Does anyone know the molecule name? That's right, it's benzene. Benzene. What if we pull an H off benzene? There's an H off each of the carbons. What if we pull the H off benzene and we stick it on a long chain? What is that substituent called? If a benzene is attached to a long chain, a benzene ring is called a phenyl. It's a special name. You have to memorize it. What's interesting is the IUPAC name for this guy is methylbenzene. But there are cases where in IUPAC the common name has supplanted the name supplanted a name, and in this case methylbenzene is generally not used. IUPAC has adopted a common name and used it, and that is toluene. This is the molecule toluene. Now, what happens if I attach a toluene through its CH2 to a long chain? That is, I pulled an H off the methyl and I attach it to a long chain. Well, guess what? You might have thought phenyl was going to be called this, but this group is called a benzyl, and you must memorize that. You might wonder why it's not called toluene. And the reason is if you pull hydrogens off of the ring, you can get 3 different toluenes. So it's when you pull H's off the benzene ring and attach it, and you don't get. So if the CH3 is left untouched, pull an H off the ring, and you attach it to your squiggle, your long chain, then this guy is called orthotoluene. And orthotoluene you don't need to know right now. We'll learn about orthotoluene. The next one is metatoluene and paratoluene when we get to aromatic sections of the course. Let's look at some other substituents that you can get off of a side chain. Well, we can get all of the halogens off. If we get the halogens off of a side chain, a long side chain, what do we call a halogen substituent? Well, the fluorine, chlorine, and iodine and bromine, INE endings, are dropped and they're replaced with fluoro. So this becomes a fluoromethane. Remember, longest carbon chain is the root, so here is a fluoromethane. What's interesting is the common name for this substituent is by naming it as an alkyl fluoride. So, and this is all one word. If it looks like there's a space here, no space, okay? So this is all one word. But when you name it common, this is IUPAC. Common names name these things as alkyl halides. That is, you would say, methyl, fluoride. Because it's negatively charged, the fluorine is viewed as being a negatively charged species. It's electronegative. It would get the ID ending, fluoride. So in the common nomenclature, you use fluoride, bromide, iodide, chloride. Okay, so fluoride, chloride, bromide, iodide. But in the IUPAC name, they come out front with substituent names as fluoro. By the way, you might ask, do you need a 1 here? And yes, certainly you could put a 1 fluoro. In the case of methane, though, you can drop the 1 because it's a methane. There's no other place to put it. It is 1. Has to be 1. Can't change that. Let's do an ethane. Let's make this an iodine. What would the IUPAC name of this be? 1-iodo ethane. That's IUPAC. What's the common name? Ethyl. Ethyl iodide. Ethyl iodide. All right. Do we need the 1 in iodoethane? In actual fact, again, you could drop that 1 because no matter where I put the iodine, if I put the iodine on the other side, you number from the, give the lowest number to a substituent possible, it would still be 1 iodoethane. So it doesn't matter. What about this guy? Propane. Let's make it a bromine. Well, what we have here is a IUPAC name 1-bromopropane. 1-bromopropane. The common name is n-Propyl bromide. Do we need the 1? In this case you do, because you could get this molecule. And if you put the bromine here, it is not 1. So you need a designation in IUPAC that distinguishes between these two molecules, and this is 2-bromopropane. And what we have next is the common name. Can you guess what it would be? What is this alkyl group? That's not a propyl. It is an isopropyl. And you have to memorize that. Notice that the common names separate the alkyl from the halide. So this would be isopropyl bromide. 2 words. So whenever you write the common name, you've got like isopropyl bromide, n-propyl bromide, ethyl iodide, methyl fluoride. They're all 2 words. But when you write the IUPAC name, it's all 1 word. Now, another substituent that you may run across is, off of a long chain, you might have an NO2. An NO2 is called a nitro group. A nitro group. Okay, well, we've covered a fair amount of ground. We've looked at substituent names. Those substituent names are used throughout both IUPAC nomenclature, and you saw they work their ways into common nomenclature. And so we see isopropyl bromide, isopropyl, being used not as a substituent name, but rather it's being used in a common nomenclature. Next lecture, we're going to extend this and start looking at some functional groups and start trying to name some of the more complicated functional groups, alkenes, alkynes. So there you have it. Hope this is useful.